Welcome back, dear children. Myself, Sir Sunil, your physics teacher. Good morning to one and all. How are you, students? I hope you all are fine and also you all are safe. So, we are discussing our unit 3rd, energy. From this chapter, today we are going to discuss one important point, conservation of energy. All of you, please take out your book and ready to watch this video carefully. Okay, students, here is our topic, conservation of energy. We have read that in transformation of energy from one form to another required form, some part of energy is changed to non-useful form also. In case of transformation of energy, once a particular type of energy is transferred to another type of energy, some unuseful energy also produced. Last class we have discussed that is called a dissipated part. Some dissipated part of energy also formed. But the total sum of the useful and non-useful energy is same as the energy being transformed. That means energy remains conserved. Energy remains conserved. For example, if 100 joule of electrical energy is converted to mechanical energy in an electric motor, it is possible that 60 joule is the mechanical energy and remaining 40 joule, total 100 joule is there, remaining 40 joule, 60 joule is already converted and 40 joule may be heat and sound energy. Thus, the law of conservation of energy can be stated as follows. The total energy is always conserved in each transformation of energy. In mechanical energy, for transformation between the potential and kinetic energy, the law of conservation of mechanical energy takes the following form. In absence of friction, the total sum of the potential energy and the kinetic energy remains constant. This can be easily understood by the following examples. First, we can discuss an example, roller coaster 1. A roller coaster operates on the principle of conservation of energy. Roller coaster operates by the principle of conservation of energy. Here is one diagram. Okay, this is one diagram 3.23. Just observe it. The movement of a car. Clear? A movement of a car we can see here. In this figure, initially some work is done to put the roller coaster car at the position A. See, here in the position A, first of all, see the position of car in first time, that is on A. That means potential energy is E, kinetic energy is 0. Okay, students. This work done is stored in the roller coaster in the form of potential energy, that means E, and since it is stationary at A, its kinetic energy is 0. As it starts coming down, if this car starts coming down, the potential energy changes into kinetic energy, means the car starts to move. Once the car starts to move, its potential energy automatically changes to kinetic energy. So, the potential energy decreases and the kinetic energy increases. Okay. When the roller coaster reaches at B, here you can observe the diagram. When the roller coaster that reaches the position B, what is the kinetic energy is E? Kinetic energy is E now, potential energy 0. Okay students, when the roller coaster reaches at B on ground, means ground, the potential energy becomes 0 as it has converted into kinetic energy. So, the kinetic energy at B is E, and due to this kinetic energy the roller coaster rises to reach the point C. During the motion from B to C, from position B to C, the kinetic energy changes to potential energy. Therefore, the potential energy increases and becomes E1, while the kinetic energy decreases to E. Its kinetic energy is E now, that decreases to E minus E1. Thus, at each position A, B or C, in case of roller coaster, the total sum of potential energy and kinetic energy remains same, that is equal to E. Here we have neglected the friction. Okay, don't forget, we have neglected the friction. Now we can see the figure 3.24, figure 324. Okay, just observe it. The conservation of energy in the motion of a roller coaster. The conservation of energy in the motion of a roller coaster. Just observe here. In this figure also illustrate the conservation of energy in a roller coaster, showing that at each point the sum of potential energy and kinetic energy is 40,000 joule. Okay. And second example is a vertically falling ball. A ball, suppose that a ball falling vertically downwards from a height is another example of conservation of mechanical energy. A ball falling vertically downwards from a height, that is another example of conservation of mechanical energy. In figure 3.25, just observe it, different position of the ball here, you can observe it, position A, position B and position C. In figure, when the ball is stationary at a point A at a height h above the ground, potential energy is maximum, that means that is E. Okay, that is E. Potential energy is E. Then the kinetic energy is 0. The kinetic energy now that is 0. Okay students, then while the kinetic energy is 0, then when it will change once the ball starts to move. As the ball starts falling down, its potential energy changes to kinetic energy, okay, at the point B, means at the height half, clear, means h by 2 above the ground, half of the potential energy converts into kinetic energy. So at B, potential energy is E by 2 and the kinetic energy also E by 2. Half of the distance is covered. On reaching the point C on the ground, whole of the potential energy has converted into kinetic energy. So at C, potential energy is 0 and kinetic energy becomes E. Thus we notice that during the vertical fall of a ball, if friction due to air is neglected, the total sum of potential energy and kinetic energy at each point of its path remains same. Okay students, now we can have an activity here. Take a tennis ball, release it from a height on a hard ground. You will observe that the ball after striking the ground bounces several times. Okay. So can you answer these questions now? What is the potential energy and kinetic energy when you release the ball? And second question is, why does the ball bounce back after striking the ground? Third observation you have to do in this activity, from where does the ball get the kinetic energy for motion after striking the ground? Okay, these 3 points, this activity you can do yourself, okay, yourself, ball activity, and these observations you write in your notebook and we will discuss in the class itself. What are the observations you can see while doing this activity? Okay, mark it in copy, and when class starts we will discuss in the class. Okay, it's your homework. Okay students, now we are going to discuss the point production of hydroelectricity. Water in motion in a river or sea has kinetic energy. The energy possessed by the flowing water is called the hydro energy. The energy possessed by the flowing water is called the hydro energy. The most important use of hydro energy is to produce electricity from it. What is the most important use of hydro energy? That is to produce electricity from it. Then once you observe the figure 3.26, okay, this is the figure 3.26. It shows how to produce hydroelectricity from river water. This diagram is very important. Please make it as important, okay, and draw it in a drawing sheet, either in a drawing sheet or in a drawing copy. Okay, already I have given some important diagrams for you. Okay, then along with this one also you have to draw. Okay students, in figure 3.26 we can see the principle of a hydroelectric power plant. The flowing water of a river is collected in a dam at a high altitude. The water stored in the dam has the potential energy. The water stored in the dam has the potential energy. When water from the dam falls on the water turbine, what will happen? The potential energy of the water stored in the dam changes into its kinetic energy, and this kinetic energy of water is transferred to the blades of the turbine as the kinetic energy which rotates the turbine. As the turbine rotates, what will happen? It rotates the armature of a generator or dynamo to produce electricity. This is the process going on in hydroelectric power plant. Okay students, just observe the diagram once again. Okay, this is a diagram. Okay, and I have given this one as a homework. Okay, holiday homework. By this point we are going to wind up this chapter. Okay students, so you have to go through it, read the chapter 1 or 2 times, and if you are facing any trouble, any problem, you can ask to me directly, and next class we will discuss the exercise questions. Okay students, till then, goodbye and have a nice day.